In this video, we will solve two equations by factoring. The first equation is h squared equals 7h. The first step in solving an equation by factoring is to set the equation equal to 0. We'll bring that 7h over to the side with the h squared by subtracting 7h from both sides. So our new version of this equation will be h squared minus 7h equals 0. In terms of factoring, the first step in factoring is to look for a greatest common factor. There is a common factor between h squared and 7h. That common factor is h. So we will factor h off of both of the terms, leaving us with h minus 7 inside the parentheses. So h squared minus 7h factors as h times the quantity, h minus 7. Now that it is factored, we will set each factor individually equal to 0. So either h is equal to 0 or h minus 7 equals 0. Well, the equation h equals 0 is already solved, so one solution for this equation is 0. The other equation, h minus 7 equals 0, well, to solve that, we'll add 7 to both sides of the equation, and we'll obtain h equals 7. This particular equation may be able to be checked just in our heads. If we throw 0 back into the h's in the original equation, 0 squared on the left side is 0, and 7 times 0 on the right side is also 0. So 0 definitely checks out. If we throw 7 back in for the h's, 7 squared is 49 on the left, and 7 times 7 on the right is also 49. Some equations we can just check in our head, but if it is more comfortable to check it on paper, please check it on paper. The final statement, we're going to give our conclusion. So here we'll finish with the solutions are 0 and 7. In part B, the equation is 6x squared plus 22x equals 40. Again, the first step is always set the equation equal to 0. So to set this equation equal to 0, we will subtract 40 from both sides of the equation and set it equal to 0. The new version of this equation in standard form is 6x squared plus 22x minus 40 equals 0. Now that it's in standard form, we'll begin the factoring process. The first step of factoring will be to find the greatest common factor. 6x squared, 22x, and a negative 40, all of those coefficients are divisible by 2, so 2 is a common factor here. We'll factor the 2 out, and it will leave us with 3x squared plus 11x minus 20 equals 0. What we have at this situation is a trinomial, and this trinomial is one of the messier ones, where the a value is not equal to 1. Because the a value is not equal to 1, we're going to use the AC, or grouping approach. So we will multiply the a value of 3 times the c value of negative 20 to obtain negative 60. And the question becomes, what multiplies to make negative 60 and adds to make 11? What multiplies to make AC and adds to make B? Before we start looking for factors of negative 60, we'll contemplate the signs. Since negative 60 is a negative number, the two numbers I'm looking for will have one positive and one will be negative. Since the b value of 11 is positive, we know the larger factor will have to be the positive one. So looking for things that multiply to make 60, negative 1 times 60, negative 2 times 30, we'll bring it up over here. Other possibilities, negative 3 times 20, negative 4 times 15. There, we finally have a combination that multiplies to make negative 60 and adds to make positive 11. So we'll go back to the trinomial and use those two factors of negative 4 and 15, but when we rewrite it, don't forget to include the greatest common factor of 2 out front. We'll keep the 3x squared what it is, but the whole focus of this AC method is to split apart that 11x into a negative 4x plus 15x, and then the minus 20 will be carried down. By splitting apart that 11x again, we forced ourselves out of the trinomial category and into the larger. And the only way we can factor a larger polynomial is by grouping. So we'll group the first two terms together, 3x squared minus 4x. We'll group the second two terms together, 15x and the negative 20. We'll make sure there's addition between the two groups, and now we'll factor. We look at the first group, 3x squared minus 4x, and see a common factor of x. So we'll factor that off, leaving us with 3x minus 4. Looking at the second group, we have 15x minus 20. Both of those have a common factor of 5, which we can factor off, leaving us with, again, 3x minus 4. As a final factoring step, we will now factor the greatest common factor from each of the two groups. Since both of them have a 3x minus 4, we'll factor that off, leaving us with x plus 5 as the leftover factors. Clearly, the more complicated the factoring process is, the longer the solving process is going to be. But we have at this point factored our polynomial. We are actually now multiplying three things, 2, and the quantity 3x minus 4, and the quantity x plus 5, and that's equal to 0. So if these three things multiply to make 0, one of those three has to be equal to 0. Of those three possibilities, though, 2 could not be 0. Since 2 is a constant, we know that 2 is not equal to 0. So that could not be the factor that's equal to 0. So instead, it has to be either the 3x minus 4 or the x plus 5. Bringing our work back up to the top over here, we'll set each one of those equal to 0 individually and solve. If 3x minus 4 equals 0, then we add 4 to both sides and we obtain 3x equals 4. And if 3x equals 4, we would divide both sides by 3 to get the value 4 over 3. Or the other possibility is that it was the x plus 5 that was equal to 0. If we set x plus 5 equal to 0, we would subtract 5 from both sides and get x equals negative 5. This is a situation where you would probably want to use your calculator to check that 4/3 is a solution for that equation and that negative 5 is a solution for that equation. The more complicated your solutions are, the more likely you should be to actually verify and check your work. Off to the side on my calculator, I did just verify that 4/3 and negative 5 are solutions. Since I'm comfortable with the check that I perform, I'll give the conclusion. The solution set is the set 4/3, negative 5. Again, it is always encouraged that you check your work. And the more complicated or messy the solutions end up being, the more you should be rigorous about checking your solutions.